Understanding Materials Lecture 4 by Lee Burton. In Lecture 3, we saw how to treat electron waves as frequency coordinates. And how a 3D grid of frequency coordinates is needed for materials. This grid has a few names: momentum space, reciprocal space, or K-space. K-space is shortest though, so it's the most common. A position on this grid can be called a wave vector or a K-point. For example, you can have a K-point of 0, 0, 0. Just like atoms have a unit cell in real space, waves have a unit cell in K-space called a Brillouin zone, named after the French scientist Léon Brillouin. The shape of the Brillouin zone depends on symmetry. This is the real Brillouin zone shape for silicon. So we have the real unit cell of silicon on the left and the real Brillouin zone shape of silicon on the right. It is shown as a solid shape, but really is a grid of coordinates, built out from the frequency coordinate 0, 0, 0. As are all Brillouin zones, in fact, meaning zero frequency in x and y and z directions. The symbol used for coordinate 0, 0, 0 is gamma, which is the capital form of the small Greek letter gamma. We know each frequency coordinate has an energy. So if we sample the Brillouin zone, we can recover the energy landscape. There are specific paths to sample for any symmetry, where letters denote special symmetry points. These letters are the labels on the band diagram. Notice that we already saw gamma before. The other symbols are more specific to silicon. L is the center of the hexagonal face. X is the center of the square face. U is the center of the edge between hexagonal and square faces. K is the center of the edge between hexagonal faces. W is the corner between three faces. So moving from left to right on the band diagram, the diagram samples the Brillouin zone as follows. Notice the vertical lines on the band diagram mark changes in the direction of the Brillouin zone. There are 230 possible symmetries for materials, so nobody bothers to remember these details. They are all available from reference literature, or more commonly these days, a website. The Bilbao crystallographic server is free and has the data for all symmetries. So any material you are working with is there. Now we know both axes of band diagrams. In Lecture 5, we will see how to read the bands themselves. Understanding materials, end of Lecture 4.